Hi, good morning. I hope all you are doing something well in UVM. Okay, so no issue. Let's we start something again with the system Verilog topic. That is a fun new topic like what is the system Verilog data types, right? So here I explain to you something what is the system Verilog data type. So just a minute, I explain to you something. How is the like system Verilog data type is working? So first thing is there like just a minute. Okay, so which is the system Verilog data type and how we use that all the data type with the help of this system Verilog platform or in Notepad++, and how we execute in this, that also I explained to you something. So let's we take something new. This is the new, right? My this new file you open from in the new Notepad++ from the file, then new, and open the new file, right, from this. Okay, so let's start with this. So let's what happened, like in the system Verilog, what happened, two type of the data type is there. One is the like two-state data type is there, and another is the four-state data type. Okay. So let's start with the four-state data type. So if you have a knowledge about the like Verilog, so in a Verilog also some data type is there like a range and wire, but here when you come towards the system Verilog, so the data type is four-state data type, and in this four-state data type is one data type is there, that is called the logic data type, right? This is the four-state data type. What is the means of four-state data type? This four-state data type means the default value of this logic data type is X, Z and 0 and 1, right? This is the four-state data. That's why it's called as a four-state data type, because the default value of this data type is in the form of the four value like X, Z, 0 and 1. Another data type that is called the two-state data type, right? So something is there like this is the two-state data type, and in this two-state data type, which data types come? One is your bit data type, another is the byte data type, then after sort int, here one is the sort int, right? This is one data type, short int, right? Then after the int, then after long int, long int, then after one is the struct, then after one is the enum, right? Let's see, short int, long int, then after one string and one other type def, right? String data type, and then after the type def data type. So let's first we think like why we introduce that all data type in the system Verilog, right? We have the Verilog language, right? So inside this Verilog language we have two data type, that is one called the wire and one called the range. We have two data type, just think we have two data type, then why we required that another system Verilog data type? SystemVerilog is what is SystemVerilog is one enhancement of the Verilog, nothing else, right? Something is a problem with the language of the Verilog, so that's why like someone is think about like we have to create some another language. By that we can able to verify the circuit by good way. So that's why at that time the different data types came in the picture. So 4-state data type and 2-state data types like that, right? So now I want to tell like this is the default value of that logic data type is X, Z and 0 and 1. This is the 2-state data type. Now in this the bit data type is unsigned by default, unsigned, right? And byte is signed. Byte is the signed data type, signed data type. Integer short int is also byte data type. Integer is also signed data type. Long int is also signed data type. Long int is also signed data type. Now something is the value, right? This is the signed and what is the unsigned that I will show to you, like how that will affect in your programming in the range, right? So we are talking about a Verilog came in the picture, right? So in this Verilog the raised data type is there. Why we are using raised and when we have to use the wire? When we are using the raised data type, so inside the procedural assignment. So now what is the procedural assignment? So procedural assignment is inside that is the initial and always block is there in your coding. That is called the procedural assignment. Procedural assignment. So when you are using the raised data type, at that time the variable inside the procedural assignment must be a raised type. This is the rules of the Verilog, right? You can write like raise 1, just giving the example, raise 1 equal to something like a. So this left hand side variable is must be a raised data type. If you are using the wire data type here, so that things is going to be, that things giving you a pop-up in the form of the error. So this is the like limitations of that raised data type. And we are using the continuous assignment statement, right? So the continuous assignment statement means assign. That assign is come under the continuous assignment statement, right? So assign wire, this is the one data type, wire 1 equal to something b. So what is happened, the left hand side variable inside the continuous assignment that must be a wire data type. This is the rules of the Verilog. If you violate the rules of the Verilog, then that's creating the problem in your programming, right? This is the limitation. So what is happened when the SystemVerilog came, at that time they introduced a new data type that is called the logic data type. And this logic data type you can use at anywhere inside the continuous assignment, inside the procedural assignment, and you can use the left hand side and right hand side, no issue, right? That's why this 4-state data type is also come inside the picture of the SystemVerilog. This is also a 4-state data type, this wire and the reach, right? This is the limitation, and that's why the logic data type is introduced in the SystemVerilog, right? So now let's we go towards the SystemVerilog data type, how we are defining and how we are using in our programming when we are using towards the verification, when we are going towards the verification side. what is the happen, like the system verilog is the constraint random verification. System verilog language is nothing but the constraint random verification, right? So just assume I show to you like how you are assuming. This is the paint, right? Assume you have one IC. That IC have like lots of pin. Just assume and keep in your mind like you have a microcontroller 8051 IC, right? This IC not up till now the programmable. Simple IC is there. No any coding is dumped inside the IC. So just think simple IC is there. So IC, what the IC have? The number of pin is there, right? And each pin have a different functionality, right? So let's we think like that. This is your IC, and this IC you have like a number of pin. Right, this your IC have a number of pin. Or assume this is your FPGA something. This is one FPGA. Now someone just think someone is giving to you this IC and someone is telling to you use that and verify that all the circuit is. So before that circuit like before that IC someone is saying to you the verify. So when you verify something, just think in your life you have to verify something. So how you verify? You know something about the like how the behavior of that. Then and then like we can able to say like I can able to verify that things. If you know the functionality, if you know the behavior, then and then you able to do the like verification. If you know that pin is like for the reset, just think this is your reset pin, right? Now when you are applying a 1 or 0, like in which part you are want to do your functionality. If like I want to, I said like when 0 is came, right, from this reset, at that time that all the circuit is going to be in the state of the reset, right? So when we apply the 0 from here, at that time whole the things is like I write something inside the code that we can say that like this is the our RTL. Inside our RTL we can write when the reset is came, at that time something is happened or something is run on this all pin, or something might not be run something on something pin, some pin, right? So these things is like that. So what is happened, this is I am giving to an idea about that because like as a verification engineer how you have to think. Just think you have one IC and you are applying something input on the like IC, and we are verifying the internal circuit of the IC like that behaving well or not. If your circuitry is behaving well, then you can say like your verification is good, or not your verification is good, your functionality is working properly, like what you want to do, that is happening. But assume when we applying the reset, right, 0 you are applying here on the pin of the reset, but not all the pin is going to be towards the reset. So this is what, this is a bug inside your circuitry, right? So this is like a basic our idea about towards if you are going towards the like verification, right? So we are going towards our main goal, right? So I keep something here, I write some code, and then after I explain to you, so you can never bother about like what is happening and how this is going on. Okay, so keep this. Now I save it. Just a second, give me some time because I want to write some code for you. So by that you can grab some idea about like what is happening inside that all the things. So this is my Verilog material. Inside my Verilog material, system Verilog is there, and here I write something that is your data type. Here I have to write want to make some new folder. I want to make these videos like something long, because all one understand like what is happening and why these things is going to be happening. Okay, so here I have to write like data type dot sv. When you are saving the file of the system Verilog, at that time the sv extension is used, right? So enter here. See, this one is going to be saved. So now we start something. So just assume we are returning the code now. This is our module and your module name. Module is a one keyword of the system Verilog, of the Verilog. So here module, and then after module name. This is the module name, means the data type. What this is a user defined data type, so you can keep anything what you want. Everything what you are returning, right? Inside this system Verilog, one oops concept is also there that I explained to you in my next video. But here one module is there. Just right now you just think like what is the data type. Forget everything about another things. And module, right? So what is you have to write it, that always you have to write inside the module and module, right? If you know the concept of the like oops, so it's good for you, and this is a nice video for you if you are knowing about the oops concept, right? Because here I am using some oops concept. So this is the module, and this is the standalone activity. This is inside the module. So and this is the standalone activity, and one is the dynamic entity, and that dynamic entity come under like dynamic. Inside the dynamic entity, class and all the things is can, and inside the standalone activity, one module and one program module is program is also there. So this is the module, right? Now just assume I write the class data type, data type of sv, right? This is class. This class from here starting like line number 36 to 65, and here you are doing the end class. This class concept come under the oops, like oops and all the things, like how we are using the class and all the things. So this class means from line number 36 to 65, that is a dynamic entity, and line number 34 to and module means line number 70, that standalone entity, right? So something rule is there, like which we can define inside the standalone activity, and which things we have to define inside the dynamic entity. Some rule is there, right? But if you are like doing the practice well inside the SV, so then after some time you know about like which things is come and inside the standalone activity entity, and after inside the dynamic entity. So let's we start something like we are making one class, and inside this class we are using some data type of the system Verilog, that is like a bit. This is the bit A, right? just assume I kept only one, then after we put more and more inside this only. So I am not doing anything here. Inside one class I take one variable, one data type, that is a, right, and this is the bit data type. Now what is happened if you are using the class inside your module? So you have to make the handle of that class, right? By the handle you can able to use all the property of that class and the method of that class, right? So what is happening now? I am writing I have to make the handle. So how to make the handle? What is the definition for to create the handle? So handle by the class name. This is your class name, and then after the user defined name, like making the handle underscore h, this is your handle, right? This is your handle, this is the handle. Now by using this handle you can do anything inside your procedural block. Now applying here, like from there we have to creating the, now applying the input. So initial begin, and then after the end. Now you are creating the handle. Now what happened, this handle not having the memory, so we are providing the memory to that handle. So handle underscore h is equal to new, this new. By this new we can able to provide the memory to the handle, right? Now I am using this handle, this handle, right? This is your handle. Now you are making the handle of that, and then after you are creating the object of that handle also, right? Now just assume you are using the rand data type. Here you are using the rand data type. So this is the randomization. Why we are using two things is inside the SystemVerilog. One, the data type has the rand property, and another data type has a randc property. This rand and randc is using for the like randomization. So this randc is like randomized cyclically, and this is the simple randomize. Now what is happen after this randomize and all the things that I explained to you step by step, right? But here you just think the rand is using. Now what is happen that in the SystemVerilog rand is there, right? This things is provide you to the randomization. Means assume what is a randomization. Randomization is nothing but you have one IC, and that IC you want to verify. So at this, just assume like you have a pin, right? And that pin is like of the 8 bit. So the number of input you can apply on that pin is 2:8. That much amount of input you apply, you can able to apply on a single pin, right? Here just I am giving the like dollar display. So dollar display value of the a, right, is equal to %d, and here the value of a, right? So here I am just think, here I am not providing any input to the a. Up till now I am not providing, but here what I am using the rand, right? So that automatically that rand providing input to this a variable, right? That's why we are using the rand keyword here. But assume if you are not using the rand, so what you have to do, that bit you are defining, then after you have to provide the value to also that bit. Like here you have to provide the a is equal to 0, 1 tick b 0, right? So that's why we not want to provide the value. That's why we are using the we want like that automatically our computer and our that software take the value according to that randomly that value is taken by this software. So that's why we are using here the rand keyword, right? Now you are doing that. Then after you are providing, you are creating the new things. Now you have to be doing the randomization. So now you not have to do anything here, just you are creating the handle, and after the handle you just write the displaying here, right? So just I take that the display here at the below side, this one at this one, right? Now we are randomize that thing. So how you have to randomize? So you have to randomize by the assert and your handle name. Your handle name is what? The handle underscore h dot randomize is one method of the SystemVerilog randomize, right? This is the things. Now what you are doing by this method, you are randomize, you can able to randomize all the variable that you are defining inside your class. Without this method you can't able to randomize that things. So that's why we are using that randomize things. Now let me see, we want to print that handle underscore h dot. Let's see, now this things is going to be completed. Now I want to run that program, so I have to go towards this one. So here I go in command prompt. This is the open containing command, and here I have to write something like a command I have to give, that is like q where we blocking, and which one is my file is blocking, copying, and data type lecture, data type underscore sv. Let's see what is the name of the class, data type dot sv, data type underscore sv, right? So this one is my, so enter here. So by the command prompt you can able to use. See, these things is the first compiling. With the help of this qverilog command you can compiling, and you can also the simulate that all the code. So this is your compilation part, and from here that is simulation is going to be start. Let's see, that things is print the value of the a. Alright, see here, this value is going to be print. This is the bit data type, and bit is in a single bit data type. So that's why that's shown here only the single value. Just think now I am using this bit data type is like a 3 bit, so 2 down to 0 I kept here, and this is now what happened, this is the 3 bit. So the range of this 3 bit value is from the like 0, 0, 1 and 2. So 1, 2 and 4 means like 7. I explained to you that things is also 0 and 1 and 1, 2 and 3, right? 1, 2 and this is your 4, right? 1 to 4. So you have on a 7, 0 to 7, this is the range of this value. So now you print again and again. So here you can able to do that things is like, so the value of the a is came in between the 0 to 7. Now let's be again compile and simulate that things. Let's see what happened. This is the randomization things, because we are using the rand keyword before this property. So that's why like anything value is that can pick up. Let's see what is the value is picking by that 5. Now they're taking the 5. But assume you are applying something that now the constraint I not have to take in this lecture, but after then we take the lecture of that. This is the, yes, this is the unsigned, right? That's why the value, the range of this is the like 0 to 7 bit. But assume your rand bit, let's we take the byte b, right? So the range of the byte is equal to the same as the 8 bit. Byte is equal to the 8 bit. But what is happening that this is the signed data type. So the range of this value is like 8 bit, right? So some negative value is also there and some positive value is also there, right? So let's think which value is taken. Now if I want to provide some specific value to this byte, right, so that I can able to provide, right? So let's think we are doing the, so how we can able to provide the particular value to that data type. Just assume first I am giving to the value of the a is equal to must, I said a must have to take 3. So I have to, what in this situation I have to do, I have to write the constraint for that, because I am forcing to that before I write these things, that a is pickuping anything value that is randomly taken by the a. But now what I am doing, I am keeping some limitation on a. I said a have to take 3, right? So that's why how I have to write, how I can able to do that things, constraint. Then after the user defined name a underscore c, then after I have to write here the a equal to 3. This is the constraint, right? Now then after I explain to you which type of the constraint is inside the SystemVerilog and all the things, but just assume how we can able to keep control on your randomized variable. So with the help of the constraint you can do that. Now let's see the value of a5, a come before that 5. See here, now this a variable must have to take the variable 3, because I write here that things, right? So let's see that things is happen or not. Just assume, because you are doing the randomization here, right? So randomly some bit is taken, randomly some value is taken when you are saying like rand keyword before the property. See here the 3 is came, because why that 3 is taken, because you are providing the constraint here, you are providing the limitation to that a variable, you are controlling this a variable. I am saying by this instruction to the code, a must have to take this value only, right? Let's see again, I write a inside, this is the another constraint data, and constraint is the a inside 0 to 5. So a inside 0 to 5, a inside 0 to 5, right? Let's see that this value is came inside that or not, or some error is came, right? Which error is came. So how we have to write the inside keyword, just I will take the here we have to be very careful when we are using the constraint and all the things, because some specific way you have to define. Here some mistake I done, so I have to check the how you have to define. So how we have to do that things is environment we go, and let's we check that things how that we have to do. And inside this transaction class, interface, read, write, monitor, and then read driver, read sequencer, and the transaction class. This is the transaction class. See how you are using the inside keyword in that. Okay, no issue here. I check. that is the transaction class slave transaction. So how we have to define that things, just like we have to take the some syntax. See here inside and inside keyword a e inside b b inside this. Okay, not here, more transactions, so the master transaction class. See here I will show to you how we have to take that all the things is come. Okay, here you just not need to do anything, but just you have to write the where I kept my disease. So here only you have to do that things. Let's we do something and we check like our code is working or not for that. But this is the syntax, no issue. You can able to check your syntax error at anywhere. How to write the inside that we have to write on inside SystemVerilog. Just we have to check like how to define that things. Inside constraint, inside constraint in SV, right? Now you have to just check the how you have to define. So let's we search on the website. So that things is going giving to us like how we have to define. See here returning by very well way. See variable name, then the range, right? So how that things is defined. See here m data inside these things. Again we have to check something. See here that bit is defined, and then after like applying the constraint on this specific bit, so that m were inside 3 to 3 down to 7. What we are doing, that curly braces we make, we have to remove this a. Let's check again. Okay, see this is going to be run now, right? This is the inside keyword. Okay, so we have to go towards our data type lecture. So just think I want to show you how that things we are doing with the these values came specific 0 to 3. Let's now I shade to that code. I not want the 3, so I not want between the 0 to 5. I want to take something else. So what the inverted inside is there. This is the inverted inside, and here you have to write the not. Let's see that things is happen or not. Okay, now the a not taken the value in between the 0 to 5. So which values came, 6 or 7 only. Let's see again that came or not. Yes, see here that taken the value of the 7. Okay, so this is the constraint. Just now we are think only about the byte data type. This is the byte. Now I want to apply the byte data types, right? So this is the 8-bit, and 8-bit means 0 to 8 bits means how much? 128 minus, but this value is, this is the byte data type, so this value is taken. Let's we apply and we check with the help of the live practical, right? This is the b underscore c, b underscore c, right? And here I am applying the b equal equal to 128, right? These things I have to print here because that things is not going to be printed by the dollar display, so I have to just print here. And b equal to percentage d, and this is I have to write here. Here write b keyword, right? Now run. See what assertion error is came, right? So why that assertion error is came? Because you are providing some invalid value with the help of this. I am keeping the 127. Let's see, these things is going to be print now, right? But when you are providing 128 at that time, that things is showing to you assertion error, because this is the unsigned, sorry, this is the sign. So the value range is between the 127 0 to 127 positive to minus 127 negative, right? See, just think, this is become a 8 bit. If you want to check, then check it, right? This is the byte data type. Then after we came towards the short int. So the integer, first we take the integer. The default value of the integer is a 32 bit. If you are defining it int, right? So int c. So this c contain the 32 bit, right? That means is what? This c contain the 32 bit. Same as it is when you are defining like short int. So this data type taken the value of the this is the 32 bit, and this is the short int. Short int means you are providing the 16 bit, right? And then after you are one more, the long int. Long int is also one data type, so that is a long int, and long int you are providing e, right? So this is what? 64 bit. And one more things is like number of things is here. Range bit is completed, byte is completed, integer, short int, long int, and one also more data type is there like the string. So you can define the string and string a, string g, and g equal to, you can able to provide a line in double inverted comma, you have to provide the Sabir Shaikh, right? Now completed. And you have, if you want to print that things string, so here you just have to write $s is equal to g equal to $s, and here you have to write the g. Now let's we check that things is going to be printed or not. Long int syntax error, that is the semicolon error. See just things at the 47, line number 47, how that you have to solve this error. So at line number 47 you have an error of the semicolon. Just go at the line number 47, see, before that 47, here you have an error. Here you are not doing the semicolon. Run it. 51, near Sabir Shaikh you have a syntax error, illegal, expecting new. This one, these things you not have to do, or what? Okay. string G. Okay, here you are giving the B, so G. Now let's check. Near Sabir Shaikh syntax error, unexpected string illegal. String illegal means that what you want to say string. Okay, you are giving these things, that's why. Let's check. And double inverted comma, that means is well. Okay, no issue. Let's I explain to you that things, how that things is working. So here I remove that things part, because of which things that error is came. Just I resolve it, and I explain to you in that next lecture of these things. Let's check again things. See, this is going to be compiled, and then after this simulation is going on now. Okay, so another thing I explained to you in the next lecture. Okay, so just I want to show these things. Let's see here. These things is came by the A and B, that things is come, right? But if you are taking this B value is more than the range, at that time the assertion error is came. So please keep in mind, and we explain to you next things inside the next lecture. Okay, goodbye, best of luck. And if you have any doubt that things related to the UVM and SystemVerilog, kindly ping me on this. Okay, bye bye.